Surgical instruments used in gynecology. Here we will discuss part 1 of this video. These instruments are 7 types, depending upon their use in the surgery. Number 1. Dissecting forceps. Number 2. Tissue forceps. Number 3. Hemostatic forceps. Number 4. Hysterectomy clamps. Number 5. Abdominal retractors. Number 6. Operating scissors. Number 7. Needle holders. First, we will discuss the dissecting forceps. They don't dissect directly. They help the surgeon in dissecting by holding that organ or that part, so that the scalpel or any other sharp instrument can dissect it. So they help in dissection. They don't directly dissect the organ. And we will discuss mostly the tweezers, things that look like tweezers. Those instruments. These are dissecting forceps. They not only they hold the organs, they also hold the needles, so that the needle holder can again catch it to suture that incision. Now the ones we will discuss will be bony forceps, McInnes forceps, Gillis forceps, and DeBakey forceps. These forceps, as you can see, the inside of those jaws, you can see the serrations. These serrations help us in grasping those organs, and you can also see teeth in some of these forceps at the tips of these forceps. Teeth help in pulling the fascia to help in dissection by clearing the area. Next, we will discuss those 4 types of forceps that we have written there: bony, McInnes, Gillis, and DeBakey forceps. The first one is the bony forceps. As you can see here, it has a specific design on its shank. This design looks like plus marks. These plus marks are protruded. Here they are not seen as protruded, but they are actually protruded plus marks. They help us in grasping, increase the friction. Now look at the jaw. It has serrations on the inner surface. Both jaws have serrations on the inside surface that help us in handling the organ. And you can see the teeth on the B figure. The teeth help in pulling the tough fascia, and non-teeth one helps in preserving the organ. So it could be either atraumatic or traumatic. Now you have seen about teeth, there are details like 1 into 2 teeth. What does 1 into 2 means? It tells about the 2 surfaces. One surface has 1 teeth and the other surface has 2 teeth. It also means that a groove between the 2 teeth will fit it, interlock it. This is the meaning of 1 into 2 teeth or 1 by 2 teeth. This is McInnes forceps. It is very distinct. As you can see, there are 3 specific lines design on the shank. This design is very distinct from the previous one. It is also smaller than the previous one. It has a stopper. This stopper goes into a hole. When it goes into the hole, it fixes it, and the force is required to separate it again. Now there are serrations on the jaw, which are not seen in this figure, but they are actually transverse serration on the jaw, and it could be either tooth or non-tooth. Tooth could either be 1 into 2 or 1 by 2, as you have seen before. This is Gillis forceps. Gillis forceps has a specific design on its shank. Looks like steps. Look at this beautiful design. It has transverse serrations and a teeth or non-teeth. Tooth 1 could be the 1 into 2, or also known as 1 by 2. It has these specific design on its shank. It has 2 stoppers, as you can see here, which are different from the McInnes one. These 2 stoppers are here, and this specific design is here. These are the distinct features of it from previous ones. It could be either tooth or non-tooth, or it has transverse serrations on an inner jaw. This is the DeBakey forceps, very distinct. Same design as the Gillis one, but you can see on the inner surface of jaw, it has only a line which has serrations, a distinct line which is serrated. Not the whole jaw is serrated, only the distinct line. That's a specific part of DeBakey forceps. This DeBakey forceps helps in holding and handling the mucosa of bladder and bowel. That's the specific part of this forceps. There could be some differences between these forceps, as it could either be straight jaw or it could have an angulated jaw, as in the C figure. You can see the angulated jaw. Now any other distinct feature about this forceps is about its jaw's width. you can see that the inside line is same in all the forceps. The length of the width of the inner line, serrated line, does not change. Whenever you hear that the jaws width is increasing or different, it doesn't affect the line's width. Only the jaws width will increase, the plane width. The serrated line's width will remain the same in all types of forceps, whether it is straight or angulated or any type of forceps. These forceps also don't have any teeth. You can see 2.4 millimeter jaw, 2.7 millimeter jaw. Only the width of the jaw is increasing, but nothing to do with the line inside. The serrated line's width will remain the same. As we were discussing that they are not tooth in these forceps. These all are automatic forceps, and they have single line, serrated line. This differentiates it from all the other forceps. The second one is the tissue holding forceps. Remember, the tissue holding forceps are, they look like a bit like needle holder because they have ratchet, they have box joint, but they are different in the upper surface. This is the needle holder that I am holding, but the tissue holding forceps are different because the jaws are not attached to each other. They don't fix it into each other, interlock into each other. They have space, and the tips could either be serrated or could have teeth. Only the tips, not the whole jaw like the forceps. Only the tips have teeth or serrations. Other whole surface of the jaw is plain. That helps us in holding the organs. The ratchet joint helps us in fixing the organ, to fix the lumen, to fix the fascia, so that the surgeon can now continue the operation without holding it. Now we will discuss one by one different examples of tissue forceps. Number 1, Lane's forceps. Number 2, Littlewood's forceps. Number 3, Alice forceps. Number 4, Babcock forceps. And number 5, Duval forceps. Tissue forceps are not dissecting forceps. They are tissue holding forceps. They hold the tissue during surgery. Now this is the first forceps, the tissue forceps that we will discuss. In this forceps, we are seeing that there is a space in the jaw. The jaw doesn't attach to each other, and the tips could either be serrated or there could be teeth. Here there are teeth. We can see the teeth here. This is the Lane's forceps. It has teeth, it has space, and the teeth could be 1 into 2. They are 1 into 2. One teeth on one surface and 2 teeth on the other surface, and they join each other. It is a tooth forceps. It is a Lane's forceps, and it is used to in the operation to remove those organs that are not to be preserved, because it destroys or crushes them. So the organs, it does not handle bowel or bladder or other organs that are to be preserved. It only deals with the organs that are to be removed. As you can see, tooth forceps always they deal with the tough tissues. So remember, Lane's forceps are used to remove the tissues. They are not to preserve the tissues. Now this is a Littlewood forceps. This is used to preserve organs. It is different from the previous one, which is used to remove the organs. You can see that it has teeth in, it will always come with 2 into 3 teeth. 2 teeth on one surface and 3 teeth on the other surface. Littlewood surface, remember, it always used to preserve the organs, and Lane's previous one is used to crush organs, so it is used to remove the organs. This one is the Alice forceps. It is different because you can see these are not serrations at the tips. These are many teeth at the tips. This forceps is used in to deal with the organs that are tough, not bulging, like bowel. It is not used for bowel. It is used for only those organs which are not bulging, like cervix. It is used to raise the anterior lip of cervix, so we can dilate the cervix. It can be used in episiotomy. It holds the apex of the wound and keeps it apart, and it can also be used in lower segment C-section. It holds the uterine flaps and keeps them apart during operation. So remember, this is Alice forceps. What does it do? It deals with tough tissues. It doesn't deal with bulging tissues. Bulging tissues like bladder, bowel. It only deals with tough tissues. What are tough tissues? Tough tissues are like cervical lip and tail cervical lip. It deals with that. It could be episiotomy wound. It can also be uterine flaps during low segment C-section. It only deals with the tough tissues. Remember. This one is the Babcock forceps, as you can see here. The tips are serrated, but it has transverse serrations. This is the difference. Their serrations are transverse. Now the jaws, the end jaws are curved. from side view you can see that they are curved. Why are they curved? So that when we hold the tissue, it doesn't completely block its lumen, it doesn't completely block it, crush it. These are curved so that they allow the lumen to exist, doesn't crush. So it allows the bulging organs to be preserved. It deals with the preservation of organs. It doesn't deals with removal. It deals with preservation of bulging organs like bowel, bladder, and it also deals with holding tubular structures like ureter. So this is a Babcock forceps. Memorize it. Thank you. This is a dual forceps. This is different from the above Babcock because look at the tips. It is triangular. The triangular edges, they are completely like a triangle. And at the tips of those triangles you can see serrations. The serrations are longitudinal serrations. That's the difference from the Babcock. And it is a tissue preserving. It is also a tissue preserving forceps, not a tissue crushing forceps. Now revise. This is the Lane's forceps. This is the Littlewood's forceps. This is the Ellis forceps. This is the Babcock forceps. And this is the dual forceps. The next one is the hemostatic forceps. They are also known as clamps, artery forceps, or hemostates. These are the many names of hemostatic forceps. These forceps helps in hemostasis. They clamp the arteries before their ligation and cutting. In surgery, first we have to separate that artery, and then we will, before ligating it from both sides, we will clamp it from behind those sides so that blood stops flowing from the inside in the center where we have to cut it. Then after blood has stopped flowing from the inside, we will ligate it from both sides. Here we are ligating it, and then we will cut it from the center. Hemostatic forceps are different from the PS ones, but they are also serrated. Their serrations are transverse, and these transverse serrations of these forceps are throughout the jaw. In the previous ones, tissue holding forceps, the serrations, if they were only at the tips, but here the whole jaw will be serrated and it will have transverse serrations through the whole body of the jaw. That's the difference between these hemostatic forceps and the previous ones, tissue holding forceps. They could have teeth and they can't have teeth. Both types are present in these hemostatic forceps. Let's talk about their jaw. Their jaw could either be straight, like look at this forceps. This is a needle forceps, but I'm only talking about the jaw, that it could be straight, it could be curved, or it could be at right angle to the body, to the shank. Like this one is straight, it could be either right angle, it could be either curved. I know this is quite a rough curve. These are the types of jaws that could be present in hemostatic forceps. Their jaw's length could also change. It could either be long or it could be short. So this is also a variable present in these forceps. Now there will be 5 forceps that we will study. They could either be mosquito forceps, or they could be Spencer-Wells forceps, or Kocher forceps, Oshner forceps, and Leahy's forceps. These 5 types will be discussed by us. The first one we will discuss is the mosquito forceps. This is the mosquito forceps. It is a simple forceps that looks smaller and delicate. It is very small as compared to a normal size of a needle holding forceps. It is very smaller than that even. And the jaws, you already know, they are transverse serrations throughout the jaw. The only difference is that they could either be straight or curved jaws. Like this is the curved and this is the straight jaw. They could either be big forceps or small forceps, or they could either be long jaws or short jaws. That's all there is about the mosquito forceps. This is our second forceps. It is a little bigger and a little heavier than the previous forceps. The one who has seen a mosquito forceps can easily tell that it is bigger than that forceps. There is not much special, only transverse serrations, straight jaws or curved jaws. This is a Spencer-Wells forceps. Previous one was mosquito forceps. This one is Spencer-Wells forceps. Previous 2 forceps didn't have teeth. This one has teeth. But these teeth are not pointed, as you can see. They are wide teeth, wide cuboidal teeth. Here, these look like a cuboid. These are cuboidal teeth. These are Kocher forceps. They are heavier than the previous ones. Even the Spencer Wells forceps. They look the same, but they could either have straight jaw or curved jaw, as you are seeing in this figure. These are Kocher forceps. Not much difference except for the teeth. They have wide teeth. Straight jaws, curved jaws, box joint, teeth, Kocher forceps. That's all there is. This one looks like the previous one, but there's a difference in their teeth. The teeth here are pointy in the end. They are wide, but they are pointy at the end of the tips. So these are not Kocher forceps. These are Ochsner forceps. Differentiate it from the Kocher. Kocher has wide cuboidal teeth. They are not pointy. These are pointy like a spike. These teeth differentiate it from the Kocher. This is Ochsner forceps. Last one is the Leahy's forceps. It can also be used in hemostasis, but the only difference is its serrations. These are longitudinal serrations, very different. And its jaw. Its jaw is right angled. It looks like curved, but it is actually right angled. Curved is that. More curved than the curved is the right angle. That's the difference between Leahy's forceps and other forceps. Leahy's forceps is used in hemostasis, but it also deals with the tubular structures like ureter. The biggest difference about Leahy's forceps and the advantage of this curve is that it can go behind and below that artery to cover it and then to ligate it. It helps in clamping easily. It can also use this curve to clamp the tubular structures. Now these are hysterectomy clamps. Why are they called clamps? Clamp is any instrument that fixes and tightly closes their lumen, tightly closes them so that we can ligate that organ. So the clamps here are also used to tightly close the pedicles before removing the uterus during hysterectomy. That is why those forceps are called hysterectomy clamps. How are hysterectomy clamps different from the normal clamps? Look at this one. The hysterectomy clamps are different from this because it has teeth at the tips. Its jaw is more secure and the ratchet lock is much more stronger and tighter in hysterectomy clamps so that it does not open during the hysterectomy, because that will lead to serious problems. There are 6 major hysterectomy clamps and 2 that are used in cholecystectomy and also help in hysterectomy if they are used. The first one is the bony hysterectomy clamp, like bony dissecting forceps that we have discussed before. Second one is Guilliam hysterectomy clamp. Third one is Heaney hysterectomy clamp. Fourth is Mangold hysterectomy clamp. Fifth one is Zeppelin hysterectomy clamp. Sixth one is Chelsea angle hysterectomy clamp. And the last 2 are the ones that are used in cholecystectomy but can also be used in hysterectomy. One of them is Monahan cholecystectomy clamp and the second one is Leahy's cholecystectomy clamp. These 2 are mainly used in cholecystectomy. They are instruments of cholecystectomy, but they can also be used in hysterectomy. Now we will discuss them one by one. The first hysterectomy clamp is Boney's hysterectomy clamp. We have discussed Boney's dissection forceps before. This is Boney's hysterectomy clamp. How is it different from previous hemostatic clamps? First of all, it has teeth at the tips. You can see these teeth. Second, it has crisscross serrations on its jaw. We can see transverse serration, but those are wrong. It is actually crisscross serrations. The teeth are 1 into 2 and the serrations are crisscross and it is angled at his neck. Note, it is not straight, it is angled. So Boney made a clamp and gave it an angle. So is Boney's hysterectomy clamp, which is angled at its neck. This is Guilliam's hysterectomy clamp. This is different from the previous clamps. You can see a circular space inside it. This space, in this jaw and the above ones, this hollow space, this is what differentiates Guilliam's from previous ones. There is a hollow space at the jaws. Second, you can see the longitudinal serrations at the jaw and teeth at the end. Teeth are 1 into 2. That is, there is 1 at 1 and 2 and 2. Same in the above figure. So this is Guilliam's and it has longitudinal serrations. It has a hollow space. So hollow space, longitudinal serrations and teeth. This is Guilliam's hysterectomy clamp, which has a space that separates it from all the other ones, and it could have a straight jaw or a curved jaw. The third one is the Heaney's hysterectomy clamp. How is it different from the previous clamps? You can see, look at the jaw. It has angulated serrations on its jaw, neither longitudinal nor transverse. These are at an angle. Second thing, it has crossed teeth. These are not teeth that occur at the tips. These are crossed teeth. So these are the special features of Heaney's hysterectomy clamp. It has angulated serrations, it has crossed teeth, and look at its jaw. It is not straight, it is curved. And you can also see in the below two figures, both the jaws are curved. This is also curved, and this is also curved. There is special feature about teeth. The teeth, they don't occur at the tips, they occur inside the jaws. One has teeth and the other surface has grooves. And there are two types of Heaney's clamps. One can have one teeth, or other clamp could have one type has one teeth and the other type has two teeth. Both have angulated serrations. This is main gold hysterectomy clamp. Look at its jaws. One jaw has a blade and the other has a groove. It is made in such a way that the blade goes inside the groove and fixes inside the groove. That's the difference between this one and the other ones. Now, the teeth. The teeth are 1 into 2. That is one teeth on one surface and two teeth on the other surface. And the jaw, it has special name. The blade one is called tongue and the grooved one is called groove. So it is a tongue and groove jaw. This is the main gold hysterectomy clamp who has a tongue and a groove jaw. This one is Zeppelin's hysterectomy clamp. It is a very plain clamp. Look at its jaws, they are so plain. No groove, no serrations, nothing at all, no teeth. Just a plain forceps. That is so special about it. It is just a plain forceps who has a strong lock at the ratchet, and it is a plain tissue preserving forceps used in hysterectomy. And it has a small hollow hole like before ones, but it is very small. Now this one is the Chelsea angle clamp. This is different. We will differentiate it from the Bonnie's one. First of all, look at the angle. This is the angulated edge. Then look at the jaws. It has crisscross serrations. These are serrations are crisscross. And the teeth. These are 1 into 2. So how to differentiate it from the Bonnie? It has a smaller jaw than the Bonnie. That's a difference from the Bonnie's forceps. The jaws are small and the shank is long compared to the Bonnie forceps. So Chelsea angle clamp is different from the Bonnie forceps due to it has angled. Second, it has teeth and crisscross striations which are same as the Bonnie's, but the angle is different and the jaw is small. The jaw is small and the shank is long. Now this is a cholecystectomy clamp. This is known as Moynihan's cholecystectomy clamp. How is it different from the previous ones? First of all, it has no teeth. There are no teeth on the tips. Second, the serrations are transverse on its jaw. These are transverse serrations. Third, the jaw is curved. So it has curved jaw, transverse serrations, and no teeth. This is Moynihan's hysterectomy clamp. Now this is the one that we have read before. This is Leahy's hysterectomy clamp. It has longitudinal serrations in its jaw. That's the only thing. Now we will discuss abdominal retractors. We have already discussed in the intro what retractors are. It has two types. First of all, what are abdominal retractors? Whenever we incise a cavity, we need an instrument that holds the walls apart so that we can do operation inside the cavity. And we use retractors for this purpose. There are two types. They could be either handheld retractors that need an assistant, and they could be self-retaining retractors. They don't need an assistant. They are self-retaining. They have a screw. There are 5 handheld retractors that we will discuss. First one is Lagenbach handheld retractor. The second one is Morris. The third one is Doyen. The fourth one is Deaver. And the fifth one is D. Lee handheld retractor. There are 3 self-retaining retractors we will study: Balfour, Gossett, and Turner-Warwick handheld retractor. Oh, sorry. Turner-Warwick self-retaining retractor. Abdominal retractors. First type is handheld retractors. Among them, the first example is Langenbach handheld retractor. This is Langenbach handheld retractor. You can look at the blade of this handheld retractor. It is small. This is the difference between Langenbach and Morris. Here is the Morris one. The Morris one has a wide and large blade.
This is the difference between Langenbeck and Morris handheld retractors. This is our Doyen handheld retractor. During C-section, we have to separate the bladder from the uterus to undergo operation on the lower segment of uterus. So, Doyen retractor is used to retract the bladder. This is the Doyen handheld retractor that retracts the bladder and separates it so that we can approach the lower segment of the uterus. This is Deaver's retractor. This is used to retract the bowel. Look how different it is from the Doyen that retracts the bladder. And this one has a huge curve on its blade. This is Doyen one. It doesn't have that sort of curve. And these are Langenbeck and Morris that are right angled. This is Daly's handheld retractor. This is Daly's handheld retractor used in general surgery to retract any organ. This is different from Doyen. Like, look at Doyen ones. This one, its curve, its arch is curved, but look at this one, its arch is right angled. That's the difference between Doyen, the curved arch. This is the curved arch that goes down curve, and this is the Daly, which has a right angled straight arch. We have completed our handheld retractors. Now we will discuss the self-retaining retractors. The first self-retaining retractor is Balfour retractor. It has 3 blades. These are 3 blades. The 2 blades that are on side by side move horizontally. They retract organs horizontally, and the central blade moves up and down and retracts vertically. This is Balfour retractor. This central blade looks just like Doyen retractor. Look, it looks identical to Doyen retractor, and these leader blades retract the organs laterally. Fawcett retractor has the lateral blades identical to the Balfour ones. These are the lateral blades. As you can see, the central blade is absent. This is Turner-Warwick retractor. It is a ring retractor, and it has many adjustable different size blades. So this is a Turner-Warwick retractor. Now, operating scissors. There are 2 types of scissors. They have a sliding joint. The 2 types of scissors could be either large scissors, powerful scissors. The large powerful scissors are used to cut the thick fascia. It is used in any major operation to cut the thick things that do not require any delicacy. They only need power. The other type of scissors are small delicate scissors. Small delicate scissors are used in operations that require delicacy to deal with small organs, to deal with small things. And the small things could be like fallopian tubes. It could be used in cutting of fallopian tubes, cutting of delicate fascia. So it is used in tubal operations or using cutting of delicate things. Both powerful and delicate scissors are a part of laparotomy sets. They are present in the laparotomy instruments. There are 2 examples of scissors that we will discuss here. Number 1 is Mayo scissors, and the second one is Metz-Baum scissors. The first operating scissor type is Mayo scissor. All scissors have a sliding joint, so difference could be something else. Here, you can see that the blades have beveling on their sides. You can see this beveling, the shining lines along them. This is the beveling. This is the beveling, formation of arch, anything you can think of. So this could be the difference, but this is only present in one type of Mayo scissors. The other type doesn't have beveling at all. They could be either straight scissors or curved scissors. These are Metz-Baum scissors. These are different from Mayo scissors. Look at the jaw, it is small, and look at the shank, it is long. Metz-Baum scissors are smaller than they look smaller and they are more delicate. They are used in delicate operations. The difference between them is that their tips could either be curved or they could be pointed. Look at them. These are pointed and there are some curved edges. The last type is the needle holders. This is a typical needle holder. You can see it. It has a small jaw, and the jaw, when you look at it, it has crisscross serrations. Crisscross serrations that happen in the gripping of the needle. These are crisscross serrations. That's the difference between it and all the other ones. Second, the jaw is small, the shank is long. It has a box joint here. It could be straight or curved. This is the ratchet lock. It is said that if you insert tungsten carbide on the jaws of the needle holder, on the inside of the jaw surface of the needle holder here, then the grip mechanism gets even stronger. That's all about needle holder. Now, which needle holders we will discuss are Number 1, Mayo needle holder, just like Mayo operating scissors. Second, Debaki needle holder. We have discussed Debaki here and the Debaki in the dissecting forceps. Just like we have discussed bony two times. The first time in the dissecting forceps and the second time in the hysterectomy clamp. So just like there are two bonies, there are two Debakis. This is bony hysterectomy clamp, bony dissection forceps, Debaki hysterectomy, Debaki needle holder, and Debaki dissection forceps. Third one is Thomson Walker needle holder, and the fourth one is Norton Morgan needle holder. We will discuss them one by one. The first one is the Mayo needle holder. Just like all needle holders, it has crisscross serrations. Then the only difference between it and the other will be that it has a conical jaw and small jaw. It is a conical jaw and it is very small. These are Debaki's needle holders. We have discussed before Debaki dissection forceps. These are Debaki's needle holders. The difference between them and the previous one will be that the jaw is long. This is the same box joint, that's the same. Look at the jaw. It is long. Crisscross serrations are same in all the needle holders, so we can discuss about that. The jaw. That one was small, this one is long. That was small and conical, this one is long. This unique needle holder is Thomson Walker needle holder. Look at the shank. It is curved. The jaw is straight. The shank is curved. It is S-shaped. This is Thomson Walker needle holder. The same crisscross serration, the same box joint, only the curved shank. Last unique needle holder is Norton Morgan needle holder. First of all, look at the jaw. It has transverse serrations. Second, look at the joints. There are two box joints here. This is very efficient in applying power when we do suturing in the deeper parts of the body where our hands cannot reach. So we need a needle holder that can apply more power with less work. So it can be used to do suturing in confined spaces. Confined spaces like operations done in the pelvis. Thank you.